What page are we on?
I cheated and looked at
Hold me now. Street from the edge, and I'm thinking.
subtracting rational expressions. It's around two.
It's true.
But we already did this.
We didn't finish it though.
I see.
That's why I didn't. That's why I didn't assign homework.
It's only half completed.
Yeah, we did like one problem, right?
We did two.
Well, there you go. Oh, okay. Let's finish 8-2. This is geometry. We don't want that. Get that out of here. Where is everybody? What the heck is happening?
I don't know. Are they still on spring break?
I guess. That drives me a little bit bonkers. And if y'all's family is some of the people that do this, yes, it does drive me bonkers. And I'm sorry, you can still be great. But people that leave for vacation early, that drives me bonkers. Stupid. Like, we're off for 2 weeks at Christmas. Why are you leaving half a week early? Oh my gosh, we didn't. Shut up.
Usually we would leave
You didn't ask either.
Friday right before, so that way we could have the day.
Well, sure. Like I don't care if you leave like after responsibilities and classes and whatever are done.
Day that you're off.
Yeah, great. Like you teach a Grace class, you leave after Grace on Friday, whatever. Or sure, that makes sense. I don't have any problem with that. People that leave on Wednesday, the Wednesday before spring break for vacation. Come on now, what's wrong with you?
When I was a kid, we would just
Prioritize.
whenever because we were homeschooled and didn't have commitments to teach.
Well, yeah, when you're little, whatever, I guess. Okay, so
I just watched too much Khan Academy. And then
what did somebody give me their notes from last time? Let's see what we did.
I don't know if you can read it. Yeah.
Wow, that's hideous. No, I'm just kidding. Oh, I'm on the wrong lesson. That's why I'm confused. Okay. All right. So we did that and that. Great. Let's do another example. Here we go. We're going to simplify 5 over 6x minus 18. Minus x minus 1 over 4x squared minus 14x plus 6. So, what should we do, you think? I agree. We should factor both denominators. Yeah, gasp is right. How can we factor this?
divide both sides by 6.
There's no sides, there's no equals.
Sorry, divide both.
Factor out a 6.
Factor out a 6.
Yeah.
Do something with the 6.
We're going to factor out a 6. I agree. Let's do that. Yippee skippy. Okay. Now, what should we do first when we go to factor this one?
Factor out a 2.
We should factor out, we should do his ECF first and then parentheses. If we do the parentheses first, we'll still have to factor out a 2 later, and this is easier, right? So your way works, but this way is easier. So let's do easier way, right? Factor out a 2. What's left when we factor out a 2?
2x squared minus 7x plus 3.
Now we do parentheses. Don't forget to bring down the 2. All right, so how does this one factor?
One of them is 3 and 2x. 3 and 1x.
2x and x.
And then
No, he's got a little cross. He's fine.
3 and 1 are only options. Yeah. And then so you put 3 on the one on the far right.
3 needs to
You want to
multiply by
do 2
2.
times 3.
3 needs to multiply by 2.
Then 1 can multiply by 1. 1 is like 106.
They're both negative.
They are both negative. True enough.
Oh, you already made negative, so.
Now, what should we do?
Yeah.
Rewrite it.
We can rewrite it. Sure, that's fine. We don't necessarily have to, but we've got a lot going on. So yeah, probably rewriting is at least somewhat prudent. Now what?
Finish the parentheses.
No, I did that on purpose this time. You came in dressed like that, and you're going to make me a crazy person for not closing a parentheses? I mean, calm down.
I think we need to clarify.
You mustache yourself. A question about.
Their friends made them do it, apparently.
So what should we actually do?
Put a, no.
Do the thing that we did last time.
thought
I
would be a
agree.
mark there.
What did we do last time, Sean?
What did we do?
I don't know.
Stop and put it to each other.
Oh, make
You also waited
That's right.
till this morning to do anything.
Yeah.
That was unintelligent, wasn't it?
Always.
Well, that's
Yeah, just
not quite true.
when you do it right before class.
I was fine though. I just watched a bunch of Khan Academy. So.
Nice.
So
We're trying to get a common denominator, right? That's our goal, because in order to add fractions, they have to have a common denominator. Oh, except there's something I'm definitely missing. There's definitely something wrong.
The parentheses.
Oh, yeah.
No, just erasing.
Yeah, because the common thing is the
Yeah.
x minus 3. And then the 6 is.
Yeah, yes, I don't have to write x minus 3 twice, or x minus 3 squared, because it exists in both.
Do I get to square it then?
I literally just said that I don't have to do that because it exists in both.
Yeah.
If it was x minus 3 squared in one of them, then I would have to have the x minus 3 squared. Okay, so when I multiply this over here, what's going to cancel?
The
X minus.
the 6.
X minus 3 and the 6. So all we're multiplying times the 5 is the 2x minus 1. Okay.
And it will be just over that second, the purple text.
Yes.
The purple text.
Wait, I thought the 5 would be divided by the. No, because we're multiplying.
Okay. When I do it on this one, what all cancels out?
The X minus.
Everything except
So why did you put the 2x next to the 5 instead of on the bottom?
it doesn't matter. Commutative property. A times B equals B times A. Always has.
But
If you want to write 2x minus 1 times x minus 3 in that order, it's fine. Doesn't matter.
No, like the 5 times 2x minus 1, I thought that would go on the bottom. Because
No.
it's the denominator.
The denominator is all of this.
Oh,
That's the denominator. What cancels, we're multiplying this on the top. We're really multiplying like this fraction times 2x minus 1 over 2x minus 1, right? That's where and we're actually multiplying this times 3 over 3 is what we're really doing, right? It's just like doing 3/4 plus 1/2. You multiply the 1/2 times 2 over 2, right, to get it as a 4. Let me write that down, since I see some weird faces happening. If I want to add those, I multiply this times 2 over 2, right? And I get 3/4 plus 2/4, and then you just add the numerators, right? So 5, and the denominator stays the same, right? That's how we add fractions. So that's what we're doing here. Now, why is it a 3?
Because you divide the 6 by 2.
Yeah, the 2x minus 1 cancels with the 2x minus 1, and the x minus 3 cancels with the x minus 3. 2 goes into 6 3 times, so 3 is the only thing that we're multiplying times that.
So why did we put a 6 up there in the first place?
Because it's the same idea, so let me write this a different way. What I'm wanting as my common denominator on this one is a 4. So if I was to write this that way, I would put a 4 here. When I multiply it on this one, the 4 cancels with the 4, and I just have a 3, right? When I do it here, the 2 goes into the 4 2 times. 2 times 1 is 2. And the denominator stays the same as our common denominator. So that's what we're doing. Does that make sense? Does that help? Okay, now what?
Scratch stuff out now, right?
We can't scratch stuff out. Why not?
Because of the subtraction.
Because of subtraction. You can only cancel stuff top and bottom if it's all multiplied, but it is not. There's nothing that cancels yet. There might be something later, but
Distribute the 5 and 3.
yeah. So we need to take care of now. There is a place, and I bet y'all can spot it. There is a place that would be easy to make a mistake. Going from here to here, or even doing it now would also be a place of mistake. Where would be a likely mistake place here?
The negative.
That negative, right? That negative applies this whole thing, right? So you can think about it now as we're distributing -3, right? If you want to think about it that, or you could do it in 2 steps if you feel better about it. Distribute the negative and distribute the 3.
I'll probably do that on the test, but not on the homework.
Right? So when we distribute over here, the only reason we're really doing this distribute is because of this minus in the middle. So we're going to kind of clean this up. The denominator, we're just going to leave factored. 5 times 2 is not 5. Did y'all know that?
It's 10.
10x minus 5 minus 3x plus 3. You know, I feel like there's some earwax happening today or something. Because I keep saying something and then a question gets asked about what I just said. I just said we're not going to distribute the bottom.
I was busy doing math in my head.
I guess.
I thought I had weird.
All right, what should we do now? The choice is clear and easy. What should we do now? What can you get rid of?
3.
We could combine like terms. I think that sounds like a great idea.
And then like reorganize it so it's not going. Put the X's in front. That's what I mean.
Put it in descending order. There's your math words.
Exactly. That's what I was trying to say.
I know. 7x minus 2 over 6 times x minus 3 times 2x minus 1. Now what?
Is that it?
Circle.
I thought that was it.
If the answer was actually this, what would we do instead? What would we do? We wouldn't circle it yet.
We would divide.
We would reduce it. Everything would get reduced by 2. It'd be 4x minus 1 over 3 times that mess, yes? Okay.
How do we go to 7?
How did we what? What?
The 7 just magically transformed into an 8 by reducing, but okay.
No.
Oh my god.
I'm swear. Oh my gosh. Like, what's, oh my gosh.
It's been a while.
What I said when it changed into an 8 was if it had been this, then we would do that. Because I was making the point that you would have to reduce it.
Vacation break.
Listening is hard. Okay, let's do a neuther one. One that looks scary. Let's pick this one. Do you need a pencil?
I don't have paper. Oh, dude, I wanted to save it. It's okay. But yeah.
Okay.
You sure?
C over D minus D over C over D over C.
And then I just didn't do it.
Well, good.
Now you get to.
Okay. What should we do, kids?
Run away because we're scared.
No, I hate that. How could we do that? Why can we, answer your question. Why can we not do that? Because the adding and subtracting and yeah, so no.
And not multiplying. Why don't we just subtract fractions? Okay.
In order to subtract fractions, what do we need?
We need to multiply the.
No, not what do we need to do. What do we need?
We need like the denominator.
Yeah. Expressed strangely, but yes. We need a common denominator. It's true enough.
Yeah.
So do we multiply by C and D? Confusing. Yeah. It was a very
How we doing?
Makes sense.
just gotta not be scared.
That is good advice. Listen to your advice. Because at this point in math, generally speaking, you're not learning anything new. You're just having bigger puzzles. All the little pieces, you know. You just got to put the little pieces into this big thing. So don't be afraid of it. It's great advice. So in the numerator over here, we have C squared minus D squared over CD, right? Pause. How we doing? Does this make sense? We understand what just happened? I'm not done writing this step. There's still a numerator to the numerator.
Oh.
But the
yeah,
top turns into this.
Because the D and C cancel out,
And they
but they multiply. by-
Yes, and C times C is in fact C squared.
Yeah. Okay. And over CD.
Okay. That would all be over D plus 2C, that over C.
So why does the C go with the 2 and not the D?
You tell me.
Because it goes at the bottom of the fraction.
Yeah, because it cancels. That's true. Now what?
We did this.
We did this.
Did this, but it's been a year.
It's been almost 2 weeks.
Close enough. Go back here.
All the more reason why it was dumb to wait till this morning. Just saying. I don't necessarily care if you make dumb decisions. I just want you to understand that they're dumb decisions. Does that make sense? That's a wisdom for the day. Sometimes you're going to do dumb stuff. Just recognize that it was dumb stuff.
I feel like I'm going to say something dumb, so
I don't know if you can do that. I haven't explained it yet, so you're not going to be accused of not listening.
Factor out the c squared minus d squared.
you factor something out.
Oh, you can. That's right. That's right. I forgot. Yeah. Yeah.
I was going to ask if you could cancel the C.
What you were afraid? I was the already said it.
Well, I was going to cancel the other C's, but I would have just said the C. But I was contemplating the rightness of the.
How do we divide fractions?
Cross
No, we don't cross multiply.
The multiply the reciprocal.
We multiply by the reciprocal. So we flip this one over. We're talking about how you can cancel extremes over means. You can cancel L stuff. We can cancel stuff in the denominators or the numerators, but this has got pluses and minuses, so that messes that up, right? So you could have, if it was less confusing to you to do this, you could have written this and then canceled. Yeah? Either way, we're going to end up in the same place. Right? Okay, so what should we do now?
Factor the squares.
You could. Sure, why not? I mean, I guess. It's fine. I think I would have just left it, but we do like to factor things that are factorable. So that's numerator, because c squared minus d squared times 1 is what?
1. Or no.
Definitely not.
The
c squared minus d squared. Yes, great. And then that factored is that, right? Because it's the difference of two squares, right? Right, great. What now?
multiply d plus 2c.
Sure.
Oh, we didn't need to factor. What? No way. But
Now what?
okay, we did, because it still is. Do we need to distribute?
Unfactor.
Turn it back into that? Is that what you're saying? So, if you circled that, I would count off 0 points. If on this particular problem, you circled that, I would count off 0 points.
That's what I was going to.
Make sense?
So that's all you can do.
That's all you can do. I can't do more than that.
If you mixed and matched, like if you did the unfactored c squared minus d squared on the top, but then did the d times d plus 2c, would you count off?
The word you're looking for is distributed.
Distributed.
No, probably not.
So as long as you have the right answer, you don't count off. Whether
That's a wild.
The instructions say simplify, and it's debatable what's simpler. Because factored versions are handy later if you have to do something with this. So this is a great simplification, and then this is also pretty clean. So, like, whatever. Okay. Let's do another one. Oh, that's weird. They put the easier example after the harder example, but whatever.
so much for that.
Whatever, it's fine.
An easy example and hopefully know exactly what it is.
Or maybe it's actually hard, but you think it's easy at first glance.
Sometimes I make myself.
Let's pick that one.
I love that.
A over B plus 1 over 1 minus B over A. Wow.
Wait,
So, what do you think we should do?
wait, can
We
we just
should.
like
No,
put one down?
no.
Get the common denominator.
They're not the same.
We gotta
So close though.
multiply the
Get the-
top one by B and the bottom one by A.
Sounds grand.
Oh.
Is the reason you do these brackets instead, the square one, the circle one?
Because magic.
No.
Look, I did it all by myself.
Did you do it right though?
I did. I did. Gotta look at. I did do it right.
I don't even know why this problem fits in this example block, but whatever. It's fine. Good practice anyway. Time is it? Great, great. We get 2 lessons today. That's good. What should we do?
Oh yeah, multiply the reciprocal.
I did A plus B over B times A over A minus B.
And then you just like,
You mentally did it in your head because it wasn't that hard of a step to make.
Yeah, I did. That's how I work very often in pre-cal.
And everyone just has to know what you
I'm curious, for multiplying fractions, instead of doing the reciprocal too, could you just like multiply sideways? That would be the same answer, right?
It would be the same answer, but it would be harder to keep track of,
Yeah.
and you would make way more mistakes.
I just wanted to know.
Yeah, no, I mean, yes, sure. But I would not recommend. First homework set.
Yeah.
Page 541. Numbers 2 through 16. Evens.
These are there's another lesson.
Just don't say anything.
Graphing reciprocal functions.
Oh.
You shouldn't have said anything. It was inevitable.
This is the next lesson.
Yes.
Actually, it was like, you're gonna complete half of it.
So we're gonna complete half of this one. That'll be right.
Dubious.
Is the 20th? Is it still really March? Feels like it should be April already.
I feel like it should be March for longer.
I just realized it's 3/25/25.
Yippee.
What did I write other than the obvious? Yeah. What kind of function?
Division.
Or
So
reciprocal
the
function.
it is a reciprocal function, and that is the parent of the reciprocal
I
functions.
could have guessed that.
You could have guessed that, but you didn't. So, failure.
In my head, lose.
You did it in your
You
head.
can't prove I did.
One of those things that just doesn't ever touch the one number, right? Like it's close enough.
it does have not only one asymptote, is the word you're looking for, but two asymptotes. It absolutely do indeed have two asymptotes. What can x not be? Zero. Why cannot be zero either?
Because it doesn't like zero.
Because it doesn't like zero. Because
1 divided by x cannot equal 0.
Because if we put a 0 here, sorry, then we end up with 0 equals 1. And 0 does not, in fact, equal 1.
That's dumb.
That's dumb. Right? Great. So, where are his asymptotes?
0 and 0.
At the x-axis. And the y-axis. If I put a 1 in for x, what does y equal?
1.
1. That was hard.
I was scared of mine for the trick.
1 divided by 1 equals 1.
So what if we did it this
The parent function sits right there. That's true enough. That's true enough. If I put a negative 1 in there, what does y equal? Negative 1. It exists right here.
You put a 0 in.
As we already established, zero's asymptotes. That's not the way we did that one already. Listening is hard. No, just kidding. Telling is more like telling jokes is hard. You have to remember so many things. Okay. Or just start saying words until somebody laughs. That's what I do. Okay. As x gets bigger, which means as the graph's going this way, what is y doing?
getting smaller.
It's getting smaller. Timing, bro, timing. So as we do our graph this way, it's getting closer and closer and closer to the x-axis. But it's never going to get there. Right? Never, ever going to happen. If I put a 1/2 in for x,
1 divided by 1/2.
don't pull your calculator out.
I did.
Good. What does that equal?
1/2? No, wait, hold on. What? Oh, 1.
How do we divide fractions?
2.
Thank you. Flip the second one, multiply. 1 times 2 is 2. If I put 1 over 100 in there, what is y? It equals 100. So as we're getting closer to the y-axis, as the x gets closer to the y-axis, as x approaches 0 is the technical way to say what I'm trying to say. What is y doing? What is the graph approaching? It's approaching infinity. When you go and you take pre-cal, we use a word to describe this. We use the word limits to describe it.
Makes sense.
Limits?
What is going to happen over here?
The same thing, but
Same thing, but flipped around, because it's going to be negative of the same thing, right?
Wait, so fractions in this thing are super easy. You just kind of like pretend like they're not there, sort of.
So that's the parent function. That's what the parent function looks like. Easy peasy.
Yeah.
does it
Two
always
little.
have two?
It always has 2. If it's a rational function, which means it's just got x's in the denominator. But when we start adding squares in there in the next lesson, then we do all kinds of crazy stuff.
What if you had C?
Well, then we have to go into the third dimension, which we don't do in here.
I want to go to the third dimension. That sounds
Okay.
kind of fun.
You can barely handle the second right now, so.
Yeah, barely handle the second, but
Okay.
it's fine.
Now, if we want to transform the parent function, we do it the same way we do everything else. I cannot stress that enough. I cannot stress that enough. Learn the pattern, understand the pattern, and you can have a basic idea of like everything. So transformation of the parent function looks like this. Are you ready?
No.
We've seen this pattern with quadratics. We've seen this pattern with absolute value. We've seen this pattern with exponentials. We've seen this pattern with actually we haven't, but
Is there no B?
it's the same pattern. If there was a B, it'd be here. And it works the same way as everything else. The dilation in the horizontal direction. We don't mess with B in here.
It's K.
That is a K. That is a K. That's true.
How does that not look like a K?
Yes.
Well, I guess it does.
So
It's a cursive K.
It doesn't.
in the parentheses, it moves the opposite. So where is the parentheses? The parentheses is here, right? So what does A do? Yes, you're not horizontal, vertical.
I was close. So close.
Well, actually, I think what you said was actually right. It reflects vertically, but it does over the horizontal axis, which I think is what you actually said. So I think you actually said it. What you meant was actually correct, and even what you said was technically correct. We just don't usually describe it that way because A is vertical. Everything with A is vertical. It's outside the parentheses, and the B would be horizontal. So that's why we describe it the other way. But what you said was technically correct. So this is either a reflection. When would it reflect?
Always. No.
If it's a negative. That's true. Yeah, it's what you were not asking what I was answering what I was trying to ask, but you were asking something that technically made sense. Reflection and or a dilation. Right? What does the K do?
Shifts vertically here.
Vertical translation is the technical term, but yes, shifts is accurate.
And it moves up for positive, not for negative.
True enough. It's a vert trans. What does the H do?
Shifts horizontally or horizontal translation.
Horizontal translation. And it moves opposite of the way you'd expect.
Yep. It moves the asymptote too. It's pretty cool. What? What's going on?
She thinks it's funny that I wrote hortrans. Horizontal transformation. Translation, actually.
If it was negative, it would go this way, and if it was positive, it would go that way.
True enough. True enough. Okay. Let's do an example. And then assign some homework.
For K, is it
Pretty.
the same thing as like the opposite? What do you think?
No.
Okay, so it's accurate. It's negative.
Yeah, it's accurate. Well, they're both accurate. It's just expectation versus reality is really what we're talking about. Let's do an example.
I used to play a game like that.
Why is that no man?
We are going to graph. Oh, that's funny.
Thank you.
Yeah, we should do that one.
I don't like that. Why do you what? Huh? You didn't say it.
Because that looks scary and looks like I'm a liar. We're going to graph g of x equals 1 over negative 3x plus 3 minus 2. What should we do?
Everything's minus 2, yeah.
I thought we weren't gonna do that.
Yeah, it looks like I'm lying, but I'm not.
We're not. This is just the one example that
No, it doesn't.
doesn't. What?
So
Oh.
It's magic.
it'll go up,
It is going to be magic.
It's not
I was right.
by
goes
negative 3.
down to. Oh, magic.
What did we do?
I don't know.
And by we, I mean me. Y'all went like,
Bye.
that's what y'all did. But what I did was that. What did I do?
You
Divide
said
out
you got rid of the 3.
I factored out
Factor now.
a 3.
So why the 3 disappear?
It didn't.
Is it in the top?
Oh, we killed the X. Or we killed the way
I could even write this a little differently that might help us understand. Because I factored a 3 out. The negative 3 in the denominator is the same as multiplying times a fraction, right? Yes. Divide by 2 is the same as multiplying times 1/2. This times 1 is itself. When you multiply fractions, you multiply the numerators together and the denominators together.
Yeah.
So that's what we done did.
Oh yeah.
So I like to, and I encourage you to, jot down what transformations are about to take place. So how does this make changes to this?
It reflects
vertical
it.
translation, horizontal translation, and
So it reflects and
dialects,
it
whatever it's called.
compresses. And compress. It also does what?
Shifts vertically
Down to
and left.
to the right 1.
Yes, right.
So, when we go over here and we go to graph the thing, what should we do now?
Make
Right
a
where
chart.
you're asking.
Yeah, we should make a, yeah, both. I agree with both. Go ahead and dot in your asymptotes, right? Where is this asymptote? The vertical one.
1.
It's at 1.
I thought you were like, I didn't take into words until after I spoke.
So I'm going to dot. That was just silly.
Yeah.
And an asymptote. Where else is there going to be an asymptote?
Down to,
Negative 2.
oh, really?
That's the one
I didn't think I was gonna be right.
earlier.
That's what you thought I was asking about. True enough. Absolutely. Yes.
I know, it's a really sad.
Now,
Omission of another graph.
now, we should do the other idea. Make us a little chart. What axis should we pick?
1. No. Yeah. Wait.
We already know what 1 is due.
Wait.
So we can do
2.
1 is literally the only
How about 2, 3, 0, negative 1? How about those?
3, 0.
We're
I
back
agree.
0 comes, that's not
Two,
this,
zero,
2.
negative ones, then it's ordered.
You want it to be low to high? Is that what you want to do? Okay, I don't care. Okay, so we plug a 2 in here. G of 2. We've got 1 over negative 6 plus 3. 1 over negative 3 minus 2.
See, like,
So negative 2 1/3. Does that sound reasonable to everybody? Did you say no? Okay, let's plug a 3 in there. G of 3. So then we've got negative 3 times 3 is negative 9 plus 3, negative 6. So negative 2 1/3. A sixth, I mean. Let's plug a 0 in there.
0 times negative 3 is 0.
Yep.
Minus 1, or no, plus 3.
1
3,
over
1 over
3 minus 2.
So negative 2/3. Wait, never.
Negative 1 2/3. Plug a negative 1 in there.
Negative 1 times negative 3 is 3.
1 over 3 plus 3 is 6.
1 over 6 minus 2. It's negative 5/6.
Negative 1 5/6.
I was so close every time.
Sort of. Now we start shoving those on the graph. Seemed like a great plan. 2, and then negative 2 1/3. And then 3 and negative 2 1/6. It's just going to keep getting closer and closer, right? Right. So this is going to look like this, more or less. And then this one, we've got 0 and negative 1 2/3. Negative 1 and negative 1 5/6. And we already know where we're headed. We're just going to get closer and closer to this line, but never get there because that's how asymptotes generally work. And so it's going to look like this.
Oh, there's 2 of them, okay.
Like the
I
parrot.
was like so confused once we got to 0. I was like, that does not work.
Always two.
So it's reflected
Yeah.
and translated, and it's hard to tell because I changed scale, but it's also compressed. It's also smooshed.
And so reflections basically just change which quadrants they're in.
Yeah, because it took this one and put it down here, and this one put it up there. Homework 2. What's the domain of that function?
Ooh. Negative infinity. Negative infinity, positive infinity.
Wait, but it has a little thing in between, so I don't exactly know.
The domain would be negative infinity to 1, not including 1, unioned with 1 to positive infinity. Right? What would the range be?
That would be
The same, but with a 2.
With a negative 2. Yeah, that's right. So when your homework sets ask you, what's the domain and range? Don't be like, I didn't know how to do that. Yes, you did. No, you knew then. I explained nothing to you. Y'all had it.
I didn't know to add the unit.
I might just say that and then be like, I forgot. I'm done.
I
Sometimes.
wouldn't know what the right, so I would have said, but not with the 1 side.
Yeah, you could have done like x does not equal 1, right?
I probably just would have brought negative infinity to like 1 and
You
then
should
it
know,
does.
just-
Oh, and then yeah, forgetting the rest of it. 8 through 22 evens. That's it. Go away. Find somebody that loves you. Strap in, because Thursday we're going to graph rational functions.
My dog
That's great.
so
They have things like horizontal asymptotes and oblique asymptotes and vertical asymptotes, and they have multiple things, and they look crazy. They're so fun. Gracias. Thank you. So proud.
the camera, my beautiful cat. The recording's still going?
The recording, I think, is actually still going.